All right, so sorry for any noise that you're hearing from the computer over there. It's really working hard on the videos that I'm encoding. We're going to talk about the S curve, and this S curve. As a matter of fact, let me go back. I can share this. It's fine. All right, so the S curve. This is actually used a lot in investment nowadays, but it's been used in technology for a while. Basically, what we're describing here is an S that slants forward and really is about how technology progresses. And so we're not talking about choice here. We're talking about cost, much more about cost and innovation. So right here, we've got the first adoption of the technology. Then it starts to go up, 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 and then it hits this exponential growth. So there's massive improvements that accelerate the advancement, becomes less expensive to achieve. So basically, it took a lot to make whatever it was happen. Let's use the totality of the electronic computer, right? So you go back to the 40s, and back here, it's super expensive, and they really have this gradual approach. And then you start hitting the 60s, and that's where mini computers come in, and you got mainframes going, and integrated circuits are happening, right, all through this. And then finally, this portion, right, where you're just sloping up, right, we're hitting the 70s and 80s and 90s, and this is just going boom, 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 boom. And the PC is becoming less expensive, but more powerful, less expensive, more powerful, less expensive, more powerful. And it's just continuing. And then finally, it starts to slow. And it's like, okay, computer prices are leveling off. Their performance is leveling off. We're not able to advance that performance as much. And we're at the end of this curve. And this meaning here, this is the adoption rate. So we're talking about slow adoption, fast, 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 super fast, slow adoption, slow adoption. So you're looking at it's becoming less expensive, and it's being picked up on much, much more. And so I actually, let me expand this out now, because I if I can. Oh, it switched screens for me, which is not nice. So it's hard to see the S curve now because it's huge. But down here, I talk about processors. Now, back in the day, gosh dang, processors just went boom, boom, boom. And you think that's happening now, and it's not. It's not happening now at all. And I tell you, a processor, we're going to deal with what we would call a single core. So nowadays, basically, you have 2, 4, 6, 8, 12, 24 processors all on one die. That's really what's happening. But because of marketing, we can't call that like, oh, you're going to have 8 processors, because the market understands a processor to be this one thing that you buy and have in a computer. And so instead, they call them cores. And so now we've got processors with multiple cores in them. Well, back then we didn't, right? And there's a bunch of improvements. I'm just going to stick with the megahertz rating. So when you have a 286 way back, this is going back to 82 or 83, the initial megahertz rating was 5, and they pushed that to 25, right? So 5, 10, 15, 20, 25, 5 times faster for that processor. You could do the same thing with the 386 and then the 486. And then the 586 was actually called the Pentium. So they started naming them and getting away from these numbers. And then we went from 60 megahertz to 300 megahertz, and on and on and on. And we're going to go all the way down to the Pentium 4 here, where you deal with 13, so 1.3 gigahertz to 3.6 gigahertz, right? So you can see that here we're going 5 times and 5 times, and right here we get, I don't know what that is. I don't know, figure it out. Is that 6 times, 8 times, something like that? And then now we almost doubled it. Then we had another jump, so this almost 10 times. And then now we start to slow down. right? So basically what happened is we kind of hit a peak here on what we could do or what they could do. It's not like I was making them. And so then the next thing you do is say, well, we're not getting a performance boost. So what we're going to do is slap two processors in there. And really, they're going to run around the same. Actually, it's slower. But because there's two of them, performance will be better. And that's where we're at. So really, this technology, right? Slow, 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 fast, 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 slow, slow, slow. Right, there's your S curve for that technology. And so that's what this really describes. Now, the move to mobile, some of the things I didn't hit on that is that there was other things going on with how do we get the smartphone to work, right? The initial move to mobile, right? You had a PC and it's set in the corner, and then you had notebooks or laptops, same thing. And that was as good as you got. And some of them got smaller, but they weren't really that small. And then you had phones, right? That stored numbers and you called telephone numbers. That's all they did. And then you had a smartphone, which was really a bunch of PDA stuff, and you made phone calls with it. That's basically what that was. So some of the other things that we needed to look at was battery. We would not have a phone that does what it does if we could not get the energy and power out of it that we do. And so I don't mean the processing power. I mean how do we actually operate this thing for more than 2 minutes? Used to have these tiny phones that just made phone calls. And if you got on a phone, that sucker was going to be dead in 20 minutes, right? So you talk on the phone, the battery just drained, your hands getting hot, and it just drained that battery. And then, oh, I got to go charge this thing, or I got to have another battery. It's very common. I had like 3 batteries, right? You know, a skinny one, a big fat one. Touchscreens were crap. So I had a PDA, and the touchscreens were always fuzzy. So if you get the PDA from long ago, touchscreen technology wasn't there. And then, of course, processor technology. Right now, what do we mean by that? Do we really need this kind of speed? Yes, we do. We need this kind of speed in our handheld devices. That's what we've shifted to. But to begin with, what we needed was not something so power hungry, something that could help us extend the life on these batteries. Right, so if you, back in the, let's use it, cell phones, the same era, had small screens, if they had one. And the battery would last about 6 to 8 hours unless you were on the phone. Meaning that if you were on the phone in 90 minutes, the battery was almost dead. So mine was small. So it was like 20 minutes, man, it's not dead. So you had to have an improvement on all of that stuff. What I'm bringing you to the attention of is that Intel, for many years, just did not change anything that they did. They basically were using the exact same technology. And I know that somebody that's really into processors would say, that's not the case. They made all these different changes. And I'd be like, yeah, but fundamentally, they were doing the same thing. Basically mooching and trying to make that 80s technology go as far as it could. And then at the same time, they weren't investing in anything else. That's a key. So an i7, this is an 8. So we're on 11 now. 1.8 to 4.6, and has 4 to 8 cores, and it uses 15 watts. AMD, because I wanted to show you that there's ARM processors out there made by AMD, made by NVIDIA, made by Qualcomm. So an R7 3700U, which again doesn't really matter too much, right? 2.2 gigahertz so it's faster. But a little slower here, so its base is faster. 4.8 cores, 15 watts. Right, that would be your graphics processor is what you're dealing with, and then Qualcomm, right? This particular processor, 2.75 to they haven't hit the top yet, and it's got 8 cores. And actually, this is would be 4 general, 8 graphics. I can't remember. One of these is graphics cores, and the other one's not. But it's using 7 watts. So if we only go off of gigahertz ratings, how fast it can process something, and we're only using that, which isn't totally accurate, you're still getting a ton of processing power for half the wattage. So that is going to spur on the move to mobile, right? Now that also is being spurred on by the move to mobile, right? So once that process starts, then these places start to understand, holy crap, we got to produce something that people will buy from us and put in their phones or their tablets. And then I already mentioned this about what they did with iPhones. Right, so that was a huge, I didn't mention some of this. That was a huge upheaval. Thankfully, I didn't experience it. Hey, I want to access my files on my phone. Right, all of a sudden for the IT industry, mobile means something big because it's like, hey, I got this little file thing here, and why can't I get on the file server with this? You know, that's what the boss is asking. And so technology is keeping up with that, and you can't. I can't, right? I access my OneDrive, you can access Google Drive, you can do all sorts of stuff with it. And then all of a sudden, IT is like, holy crap. So you want to get these files on your phone? What are you going to do with that? No, that's not your attitude. Your attitude is, yes, sir, you're the boss. Let's get those on your phone. Can I access the data system on my phone? Yes, sir, you can. Let's find a way to do that. And so in this 5 to 7 years that happens, you've got this massive shift over to mobile and everybody going clamoring and trying to keep up and trying to get this stuff. For me, right, I didn't have to do that because I was working in education, but for me, honestly, it would have been easier because I already would have been looking at products that are doing that kind of thing, knowing, and I would have been doing it right because I didn't have an iPhone or a better smartphone because I was teaching by that time and I would have to pay for that. So if my business was buying it, I would have been right in there going, I better learn how to do this. I better get this and learn how to do this. And then I would have been like, I can access files off my file server. And this is the way I can do it. So when the boss asks, I'm just like, yeah, here you go. Oh, wow, thanks. And I'm just a genius because I was already ready for that. So many places were not like that. I want you to be like that. Whatever business you're going into, whatever you end up doing, I want you to be able to say, I need to keep track of underlying technologies because if you keep track of those underlying technologies, they are going to affect a product and they're going to change how you work. And if you're watching it, then you know. That's probably 7 years away or 10 years away, or maybe it'll accelerate really rapidly. And I think it's 10 years, but it's only 2, but I'm going to watch it. That way I'll be ready and I'll have it in place and ready to go. So what will happen to your career, right? What will happen? You have to keep track of that. I want you to be as successful as possible. Take care of yourselves.